Initially, when this mass is connected to a spring on the top, to a wall on the top, the spring is in its unstretched position. Initially, spring is in its unstretched position. The lower surface is smooth. So because of this weight, this will start moving to the right, this will start going down. At one instant, small m will lift up, yes or no? At the instant when small m leaves contact with the surface, find the velocity of both the blocks. If I release the masses from the position shown, write down. If the masses are released from the position shown, find the velocity of both the masses. Find the velocity of both the masses when block A leaves contact with the surface. Block A leaves contact with the surface. In the bracket you can write, initially the spring is in its unstretched position. Initially the spring is in its unstretched position. So when this block comes here, this will be the way the spring acts. This block has come down by this. If I take this distance to be h, this distance will be h. Yes or no?
Yes.
Now at this instant, if the block is taking off from the ground, if I consider this to be theta, this will be theta. Kx cos theta plus normal force will be equal to mg. Agreed?
Yes, sir.
Now if n becomes 0, this will leave contact with the surface. At this instant, he wants the velocity of both the blocks. At this instant, he wants the velocity of both the blocks. That's the hint. Will you attempt or should I discuss? Please. Now listen. Your first equation is kx cos theta is equal to mg. Is everybody okay with this? Normal force should become 0. Second equation, have a look at it. Cos theta is a variable which you incorporated. X is also a variable which you incorporated. X is the elongation in the spring. X is the elongation in the spring. You will have to eliminate both of them or give me a relation between the two. How do I get that? Observe this. What is the present length of this particular spring? L by cos theta? L naught by cos theta, yes or no? This is theta, this is L naught. This will be L naught by, elongation will be this minus this. X is equal to L naught by cos theta minus L naught. This is my second equation. Right? X is the elongation in the spring. Present length minus the natural length. Present length is L naught by cos theta minus the natural length. Will I get the elongation? So out of the two variables that you introduced, you have a relation between them. Third, work done by conservative, non-conservative plus work done by external forces is equal to delta TME. Yes or no? Non-conservative forces don't exist. The surface is smooth. External force, normal force. From here till here it does exist. But it is perpendicular to the displacement. Normal force is perpendicular to the displacement. So work done by the external force is 0. So delta TME is 0. That means loss in potential energy is equal to gain in loss in potential energy mgh incomplete minus half kx square. The elongation in the spring, that is also potential energy. Half kx square is potential energy stored in the spring. Right? But there is a gain in it. So net total loss in potential energy will be loss in potential energy by the height minus the gain in kinetic energy in the spring will be the net total loss. Equate it to half mv square plus half mv square. Final kinetic energy of both the blocks both have the same mass. Initial kinetic energy of both the blocks is 0 as they are released from rest. 3 equations, 3 variables. Isn't it? Writing speed.
Sir,
Yeah.
sir, in the last step, why have you written, sir, mgh minus half k?
Loss in potential
Sir, in
energy.
the last,
Your doubt is why it is minus or plus. Is that your doubt?
yes, sir, that's the.
This is the loss in potential energy. Half kx square is the gain in potential energy of the spring. When you are stretching a spring, potential energy is gained by the spring.
Sir.
So net total loss will be loss minus gain will be net total loss.
So what is that minus 0 plus 0?
Initial kinetic energy of the blocks.
Sir, could you please explain the loss in potential energy part?
This write it down. So loss is mgh. Spring is stretched. So this is gain. Some potential energy has been gained. So net total loss will be loss in potential energy minus the gain in potential energy will be the net total loss. Half kx square, the spring has been stretched. So potential energy stored in the spring now is half kx square. Out of this loss minus the gain, I am left with the net total loss.
I think the work done by external force is 0.
Normal force is perpendicular to the displacement all through.
Okay, sir.
Sir, I didn't understand loss in the. Sir, I didn't understand that equation. Can you please explain it again?
pH minus half kx square. वो क्या explain करना भी समझ में नहीं आ रहा है यार मुझे. When a body comes down, will there be loss? mgh is a loss in potential energy. Till here, are you clear?
Yes, sir.
Now, when the spring is stretched, there will be gain in potential energy there. Is that clear? Net total loss will be loss minus gain. Is that clear?
Okay, sir.
Now listen. We are interested to calculate the work done by friction on both the blocks during the first 1 second of the journey. Write down the statement. Work done by friction on both the blocks during the first 1 second of the journey. Work done by friction on both the blocks during the first 1 second of the journey. Now listen. In such type of problems, first decide what is the value of friction acting on it. What do you mean, what is the value of friction? Value of friction will be dependent on whether 3 kg block is sliding on this or not. Find out A common. 7 divided by 7 will be 1 meter per second square. A maximum will be 0.12 into Z. This is 1.2 meter per second square. Right? A maximum is provided by friction. Right? Do you think friction will act to its fullest extent to give this block 1.2 meter per second square? It will not. It will decrease its value so that both move together with common acceleration of 1. So what is the value of friction acting? 3 into 1, 3 Newton is acting on it. Technically what is mu mg? Mu mg would have been 0.12 into 3 into 10. This will be 3.6 Newton. This would have been the maximum value. But friction will decrease its value from 3.6 to 3 to make sure both the blocks are moving together. We are aware of it. Now, work done by friction in this case will be frictional force dot displacement. 3 Newton is in the forward direction. Half A T square is also in the forward direction. That will be the work done. How much will this be? 3 into half into 1 into 1 square. This will be 3 by 2 joules of work. Why is acceleration 1? A common. Now what will be the work done by friction on the 4 kg block? Frictional force dot displacement. Here frictional force is in the opposite direction and the magnitude will be the same. Half A T square with a negative sign. Look at the beauty in it. If both the blocks are moving together, work done by friction, this will be positive, this will be negative. Frictional force is the same, displacement will be the same. Same acceleration, same time. Both will cancel out and become 0. Work done by friction in this case will be minus 3 by 2 joules. Plus 3 by 2 minus 3 by 2. Net total work done will be 0 by friction, of course. Right? But this will apply if and only if these two are moving with common acceleration. Suppose they are not moving with common acceleration, then for sure the work done by friction on the 3 kg block and 4 kg block will not be the same, because the value of friction may be the same because they should be equal and opposite, but then acceleration of both will not be the same. So work done will be different. When both the blocks are moving with common acceleration, net total work done by friction will be quick.
Sir, can you please explain the second and the third one equation? I didn't get that.
Please tell me your doubt, yes.
Sir, especially the third part, sir.
Reading the third part here.
Board equation work on friction. Friction into displacement.
This one or this one?
Below one.
Below one. What is the value of friction? They will be equal, right?
Yes.
Why?
Because friction is a common acceleration is given same, so the friction will be acting upward.
Every action has an equal and opposite reaction. This is friction, these both will be equal. So the frictional force is the same, 3. Displacement of this, half AT square. Friction and displacement are in opposite direction, so I put cos 180.
Yes, sir.
So at first you calculated the work done by friction on 3 kg block, and then you calculated the work done by friction on 4 kg block. So but the work done is net work done comes 0, but if the work done by friction is 3 by 2 joule, then how you can say that it is 0?
3 by 2 minus 3 by 2, how much do you want me to put here? Work done by friction on the upper block is plus 3 by 2, lower block is minus 3 by 2. Kitna डालूं net total work done by friction? 6 by 4? Switch off the mic.
Hold on.
Sir.
are not available.
Sir,
Yeah.
Sir, if we apply the same force of 7 Newton on the upper block, sir, then what will be the,
Switch off the mic. Switch
will the
off
work
the mic.
done?
Switch off the mic.
Sure.
Ah,
Sir, so by this case we can always tell that the work done by any action reaction pair is always zero.
no. I haven't told anything like that. Displacement also is same. Action reaction pair ka forces may be equal. If displacements are different, then why will it be zero? Find the work done by friction on both the blocks in the first 1 second of the journey. Find the work done by friction on both the blocks in the first 1 second of the journey. This is the 3 kg block. Friction will act in the forward direction. 6 kg block. Friction will act in the backward direction. By the by, are both the blocks moving together? A common is 2 meter per second square. A maximum is 1.5 meter per second square. All said and done, if whole of friction on this block is acting, it can make it move with 1.5 meter per second square. So work done by friction. How much is the friction? Now that this is sliding on this will be 0.15 into 3 into G. This will be 4.5 Newton. This will be 4.5 Newton.
Yes.
Work done by friction on the 3 kg block will be 4.5 into half. What is the acceleration of this? 1.5 into 1 square. Positive. Friction and displacement are in the same direction. Work done by friction on the 6 kg block is 4.5 Newton into half. What is the acceleration of this? 18 minus 4.5 by 6 cos 180. Acceleration of this block is, I am pulling it with 18 Newton, minus 4.5 by 6 will be the acceleration. Time is 1 half AT square. Force and displacement are in opposite direction, cos 180.
So why is the total work done by friction not zero?
Because the displacements are different, no yaar. Acceleration of both the blocks are different. So displacements are different. So total work done by friction need not be zero here.
Sir, then what? How did friction get that energy from the force from?
Friction get the force from. क्या पूछ रहे हो?
Sir, the total work done by friction must be zero, right?
Why should the total work done by friction should be zero? Previous case, when both the blocks are moving together, because the frictional force will be same and displacement will be the same, work done by friction will become zero.
Okay, sir. So what comes out the network done by friction?
Calculate that, whatever you get is the answer. We are ready. मुझे करना है. Find the work done by friction on both the blocks in the first 1 second of the journey. Work done by friction on both the blocks in the first 1 second of the journey. Andheri, speak loud, the others please do maintain silence. Andheri, say that again.
Sir, work done by friction can only be zero or negative, right? Cannot be positive.
Necessarily need not be. We have calculated in the previous example one situation where it is positive. Observe that carefully. Work done by friction can be zero, it can be negative, it can be positive. In the previous example on the upper block, work done by friction was positive. Observe that. In the previous two examples, work done by friction on the upper block. Previous example, work done by friction on the upper block is positive. Work done by friction on the lower block is negative. Above all, work is frame dependent. From one frame I can see positive work, from another frame I can see negative work, from another frame I can see zero work.
Sir, is it 9.92?
I don't remember the answer, I gave arbitrary numbers, I will solve it. 1 second, have patience.
Oh.
Here when you draw the free body diagram, 3 kg block, 4 kg block, when I am pulling this, friction will act on this, friction will act on this way. A maximum I will calculate for this. A maximum will be 0.16 into 3g divided by 4. Frictional force will be 0.16 into 3g. Right? Reaction of that will be 0.16 into 3g. By the way, how much is this? 1.2 meter per second square. A common will be 14 divided by 7. This will be 2 meter per second square. A maximum is less than A common. All said and done, even if the maximum friction is acting, it cannot make this move along with this. So 3 kg block will be sliding on 4 kg block. If 3 kg block is sliding on 4 kg block, what is the value of friction acting? 1.6 into 3, 4.8 Newton of a friction is acting on this. Work done by friction on the 3 kg block will be 4.8 into half AT square. What will A be? 14 minus 4.8 by 3 into 1 square. Frictional force into displacement. Now frictional force is in the backward direction, displacement is in the forward direction. Cos 180, hence it will have a negative sign. Now work done by friction on the 4 kg block. Friction acting is 4.8 Newton into half. What is the acceleration of this? 1.2 into 1 square cos 0. Somebody was saying work done by friction will always be negative or 0. Look, I am getting positive here, I am getting negative here. Do not tell me that work done by friction will always be negative. It will not. Simple example, I am getting positive. Frictional force is acting in the forward direction. Displacement of the 4 kg block is in the forward direction. So obviously work done by friction is positive in this case. Negative here. It can be 0 in some situations. For instance, when I am walking, friction work done is 0. Because the point of application of the force has 0 displacement. Yeah.
Sir, in the case of work done by friction by the 3 kg block, We are taking force as friction, but displacement as the displacement that is caused because of the force and friction. The net result.
Displacement, net displacement is force into displacement of this. Displacement will depend on its acceleration. F minus 4.8 by 3 is the acceleration. Naturally, displacement of this is the half AT square. Acceleration is F minus friction by 3. Note, work is frame dependent. Work is frame dependent. Work is frame dependent. Please understand this. You and I are sitting inside a train. Your displacement with respect to me is 0. So if you ask me what is the work done by friction on you, I will tell you the answer is 0. Somebody on the ground will see you accelerating along with the train. So you ask him what is the work done by friction, he will tell you positive value. Somebody on the ground will see you accelerating along with the train. He will tell you positive displacement. Right? So he will see positive work done by friction. If somebody on the ground can move with a velocity greater than the speed of train, then he will see you going in the backward direction. So he will report negative work done by friction. So work is frame dependent. Work is frame dependent. Now, Irdo creates a sarcastic situation where from two different frames you will get the same answer. By chance. And then next bit he is asking you, is work frame dependent? He is playing with the kids. Listen, first of all, this is a smooth hill. A block of mass m slides down the smooth hill and it will come onto the platform. What will its velocity be? Under root 2gh. Yes or no? The lower surface is smooth. The lower surface is smooth. Right? He says all this hill is only a crazy adjustment here. It is the whole of the problem starts from here. Small m reaches the top of this plank with a velocity of under root 2gh because this is of height h and this is smooth. Now he says there is friction between small m and capital M. There is friction between small m and capital M. So technically small m per friction will act this way, capital M per friction will act this way. Initial velocity of this was under root 2gh. So friction is trying to prevent slipping between the two. It is trying to slow this down. Simultaneously it is trying to accelerate capital M. At some stage, iska velocity is decreasing, iska velocity is increasing. Both of them will start moving with the same speed. Right? The plank is sufficiently long. You may say before that can be achieved, don't you think small m will fall off? Plank is sufficiently long. Viridov is asking you find the work done by friction from two frames. One is the ground frame. The second is with respect to capital M. First let me calculate with respect to ground. Then I will calculate with respect to capital M. Right? Did you understand the question? Yes. Work done by friction from the ground frame of reference. Write down the question first. After some time, small m and capital M will start moving together. Write down the statement. After some time, small m and capital M will start moving together. After some time, small m and capital M will start moving together. After some time, small m and capital M will start moving together. Full stop. Find the work done by friction on the system. Find the work done by friction on the system with respect to ground. Find the work done by friction on the system with respect to ground. Now please pay attention here. On small m, friction is acting backwards. On capital M, friction is acting forwards. Technically, I should calculate the value of friction and multiply that with displacement. Instead, I have a convenient alternative for myself. Though conservation of momentum will be taught to you in the next chapter, you have an idea on it because of Newton's laws. F external is equal to dP by dt. This is Newton's second law. Yes or no?
Yes.
If external force is 0, momentum initial is equal to momentum final. Momentum will be conserved. Why are you telling me this now? In the horizontal direction, if small m and capital M are taken as one system, there is no external force. In the horizontal direction, if small m and capital M are taken as one system, there is no external force. If I take only small m, I have an external force. If I take only capital M, I have an external force. Right? So, in the horizontal direction, lower surface being smooth, there is no external force. All of you convinced? That implies I can conserve momentum in the horizontal direction for both the masses put together as a system. That means initial momentum of the system is m into under root 2gh. Final momentum of the system small m plus capital M into V naught. Both are moving with common velocity after some time. What is that common velocity? Is this value under root 2gh upon small m plus capital M. Can I solve this using kinematics and frictional force and constant acceleration? Yes, you can. This is a bit simpler. Right? Time taken by this to reach a velocity V naught. Time taken by this to reach a velocity V naught. Equating both the times, I will get V naught. It will be the same. Now my question is, with respect to ground, in the question did you write that you are solving with respect to ground?
Yes.
With respect to ground, work done by conservative plus work done by non-conservative plus work done by external force is change in kinetic energy. Work done by conservative force do not exist here. Gravity is not doing any work. Why is gravity not doing any work? The vertically downward direction. Displacement is in the horizontal direction. Non-conservative force is doing work which you are asked to calculate. External force is not doing any work. Why is external force, normal force not doing any work? That's perpendicular to the displacement. So instead of calculating the work done by friction, if I can tell you the change in kinetic energy, that will be the work done by friction. Work done by friction, change in kinetic energy, half small m plus capital M into V naught square minus half small m 2gh. This is the V naught, this is the final kinetic energy, this was the initial kinetic energy. There is a change in kinetic energy. Who did the work? Friction. And you are asked to calculate the work done by friction. Now this will be half small m plus capital M, V naught square I'll substitute from here, m square 2gh upon small m plus capital M whole square plus mgh. 2 will go, this will go, m square by m plus capital M gh plus mgh. Sorry, this is minus. If I take LCM, I'll be left with small m capital M gh by small m plus capital M with a negative sign. This is the work done by friction with respect to ground. Half the problem. Is this clear till here? All of you? Louder?
Yes, sir.
Louder.
Yes, sir.
Yes, sir.
Wait.
सर आपने जो एक्सट्रीम राइट में ऊपर सर वो क्या लिखा है वो सर नहीं समझ.
न्यूटन सेकेंड लॉ स्टेटमेंट बता सकते हो? न्यूटन सेकेंड लॉ स्टेटमेंट.
Yes, sir. The rate of change of momentum is directly proportional with the force up.
If external force is 0, then will momentum be constant?
Yes, sir.
Now if external force is 0, momentum is constant, implies initial momentum will be equal to final momentum.
Oh, okay. Yes, sir. Yes.
Now that's what I used here. In the horizontal direction, small m and capital M put together, external force is 0. So initial
Okay, sir.
momentum is m into under root 2gh, final momentum is small m plus capital M into V naught.
Yes, sir. Thank you.
Yeah.
Now do we have to check the condition for sliding here as well?
It is sliding for sure, it has been given. This is given under root 2gh and this was at rest. So small m will slide on capital M. Only after that both will attain common velocity. Now listen. We want to calculate the same work done by friction with respect to an observer on capital M. Write down work done by friction in the above problem. Work done by friction in the above problem. Work done by friction in the above problem. Work done by friction in the above problem with respect to an observer on capital M. With respect to an observer on capital M. Now please listen. There is a man standing here. I will redraw the diagram so that I save some space here. There is a man standing here, small m, this is under root 2gh, this is capital M. Initially the man sees this block coming on to capital M with the speed. After some time, when both start moving together, the man will observe small m coming to rest. Somebody on the ground will tell me after some time small m and capital M started moving together. Somebody on capital M will tell me that after some time small m came to rest. Yes or no?
Yes.
Now we are interested in work done by friction on small m and capital M both put together. First of all, frictional force acting on this is in the backward direction. reaction of the friction is on this. So initial velocity, we will use the formula VR square UR square plus 2AR SR. What does this R mean? Relative. When will it become relative? When I put a pseudo force of M into capital A on this. This will be having capital A acceleration. When I put pseudo force, the moment I am putting pseudo force implies I am solving the problem with respect to capital M. Right? So now this man will see this block coming to rest after some time. Initial velocity of small m with respect to capital M is under root 2gh whole square. Right? Plus 2 AR acceleration of this with respect to capital M. This will be deceleration, put a minus sign. What is the frictional force? Mu small mg pseudo force M into capital A divided by small m into SR. This is the frictional force acting on small m because it is sliding. This is the pseudo force acting on small m. Mass of the block into acceleration of the frame. What is the acceleration of the frame? Capital A. Right? Now, capital M is accelerating in this direction due to what force? Friction. So now 2gh square to the left, cancelling this out, 2 into mu g plus what will capital A be? Frictional force by capital M, mu small mg by capital M. Capital A will be frictional force divided by capital M. SR is GH upon mu g 1 plus small m by capital M. This is the relative displacement of small m with respect to capital M. Initially it came with a velocity was under root 2gh. Final velocity as observed by this observer will be 0. In that time it moved a distance of this capital mgh upon mu g into small m plus capital M. This will be SR. What will be the work done by friction on small m? It will be mu small mg into SR with a negative sign. Displacement is forwards, friction is backwards. Displacement of small m is forwards, friction is backwards. Minus mu small mg into capital mgh upon mu g into small m plus capital M. Mu and g will go with this. Small m capital M gh upon small m plus capital M with a negative sign is work done by friction as seen by an observer on capital M. If you turn the page and see work done by friction with respect to ground also is the same value. It is just a mere coincidence that you are getting the same value. Work, the next question Hirdov is asking in the same question is work frame dependent? Student is tempted to say no, it is frame independent because from two different frames you are getting the same answer. When you turn the page and see the answer given behind, it will be given frame. Work is frame dependent. Right? One more clarification here.
Sir, if the block slides over the capital M block before coming to rest, then what will we do?
Say that again.
Sir, in this case, we have considered that the small M block comes to rest before it slides down the capital M block. Sir, but if it doesn't slide down the capital M block, then what will we do?
How will it not slide?
Sir, I'm telling that if the small M block falls down the capital M block before coming to rest.
Exactly. When there is friction between the two, before both start moving together, small m must slide on capital M. Do we have a choice in that?
So sir, I'm telling that it slides down, sir, it falls down from the capital M block.
Sufficiently long.
Capital M is sufficiently long here. Please given capital M is sufficiently long.
Sir.
Listen, 1 second.
Sure.
One more clarification. If you people observe carefully, in the previous case when I solved with respect to ground, listen to me. When I solved with respect to ground, I took work done by friction on both small m and capital M put together. I took change in kinetic energy of whole of the system. Here I calculated work done by friction only on small m, and I am telling you both are the same. Don't you think we are cheating you here?
So he's standing on that.
Wonderful. Displacement of capital M is 0 with respect to this man. So work done by friction on capital M is 0 with respect to this observer. This observer is standing on capital M. What will be the displacement of capital M for him? 0. So work done by friction on capital M will be 0. Work done by friction on capital M as seen by observer will be 0 because the displacement is 0. So this will be the net total work done by friction on both the blocks put together. Quick.
Sir.
Ah,
Sir, can you explain the relative displacement part?
VR square, UR square plus 2AR SR. Final relative velocity of small m with respect to this is 0. Initial relative velocity is under root 2gh minus 0 whole square. Decelerating, so negative. How will you claim it is AR? I have taken a pseudo force. Along with all the existing forces, you will add one more force called pseudo force. Friction is mu small mg. Pseudo force of mass of the block into acceleration of the frame. Force divided by mass is its deceleration. SR is the relative displacement. What is capital A? Acceleration of the frame. Why is the frame accelerating this way? Because of friction. So it is mu small mg by capital M.
Yes, sir, thank you. Sir, sir, why did you take MA pseudo force?
Who is this? What do you want me to take? Like, according to you, what should be the pseudo force then? Or is your question, why did you take pseudo force?
Sir, why did you take pseudo force?
How pseudo
Sir, because
force is
friction.
taken? Isn't it? यार क्यों मजाक कर रहे हो यार? We have spent months together learning why pseudo force is introduced.
Sir, friction provides the required force for the block to come at rest.
You are solving the problem with respect to which frame?
Sir, observer.
God is there is the observer, hanging in air, flying or sleeping.
Sir, on capital M.
Now capital M, is it accelerating?
Yes, sir.
So if I am solving with respect to an accelerating frame, I can apply Newton's laws if and only if I take a force called. Let him say.
Okay, sir.
Simply because I cannot reach you, you are not supposed to have fun this way. Ask me genuine doubts, that's all. Why do you take a force? Why don't you take some other force? Pseudo force you are asking me why I should take when we are solving with respect to an accelerating frame यार. April से अभी तक कर क्या रहे हैं हम लोग?
Sir, sorry sir, from Parth from our.
Sir, what is that statement written below the answer?
Work done by friction on capital M. You have calculated work done by friction only on small m. This is relative displacement of small m. You may get a doubt later on when you refer to your notes. Why did you not take the work done by friction on capital M? Work done by friction on capital M is 0. Why? Because the observer is on capital M. According to him, the displacement is louder.
0.
Wonderful.
0.
How we use work energy theorem is the key catch in this. Irdo intentionally gives this for you to apply work energy theorem. He tells you length of the swing is L. He is pulling this with a force F, which is always horizontal. He is pulling the body with a force F, which is always horizontal. Thane, settle down. There's a lot of noise in your room. I'm able to see noise. Quiet. Listen. The key catch in this, the concept is important. Please pay attention. Key catch is, Iridov says, the force applied always maintains a horizontal direction. But he doesn't tell you that the magnitude of the force is constant. That is left to your discretion. It may be constant, may not be constant, your choice. But he tells you that this is moving slowly. A horizontal force moves small m as shown. Find work done by this external force. Find the work done by this external force. First reason for me to be tempted to fall into the trap is you will say force into this displacement. Work done is force into displacement. Displacement should be the displacement of the point at which the force is applied. Right? Now displacement will be L sin theta. So I will be lured into the trap to say F into L sin theta. This is what Irdo wants you to commit as a mistake. This will be wrong. Because force is not constant. Did he tell you in the question that force is not constant? He didn't tell me. But he told me one information, that this force is moving small m slowly. What does this slowly mean? In physics, whenever you use the word slowly, it implies it is moving with uniform speed. So what? How does that tell you that the force is not a constant force? If this should move with uniform speed, at every stage, mg sin theta should be balanced by f cos theta. Now as theta is changing, f is mg tan theta. Theta is changing, the magnitude of f should be changing. He didn't tell you this in the question. He wants the student to realize that when he uses the word slowly, for the bob to move with uniform speed, mind my language, I am not saying uniform velocity, I am saying uniform speed. For the bob to move with uniform speed, the magnitude of the force cannot be constant. Is the point clear? Yes. All of you. Then I will have to select an indirect means. There are two alternatives. Force is not constant, then calculus comes into picture. Consider a very small time interval, limit delta t tending to 0. In that time interval, the force will be constant. Right? And integrate that work done. If not, ask help from work energy theorem. How do you ask help from work energy theorem? Watch out for this. Work done by conservative plus work done by non-conservative plus work done by external force is change in kinetic energy is 0. Why? It is moving slowly with uniform speed. I do not have a non-conservative force here. Air friction is not taken into consideration. You are asking me the work done by this external force which I am not in a position to calculate. Why? Because the magnitude of the force is not constant. But I can do one thing. I can calculate the work done by conservative. Why can you calculate? How can you calculate work done by conservative? mg is a constant force. F may not be a constant force, but mg is a constant force. This will be mg into L into 1 minus cos theta. This height, mg is downwards, this height was upwards, so I'll have to put a negative sign. Work done by conservative is this. This is 0, this is 0. You are asking me work done by external force. Can I calculate that? Without actually using the external force, you have calculated the work done by the external force. Hence, he is irreducible. Right? Make a proper note of it.
Sir,
Yeah.
sir, I understand that force is not constant.
F cos theta should be mg, only then it will be moving with uniform speed.
Yes, sir.
So F is equal to mg tan theta. As theta is changing, can force be constant?
No.
Sir,
Yeah.
sir, you told that it can be done using calculus. How?
ये अगर इस प्रोसीजर से हो गया ना, वो मेरे लिए काफी है. कैलकुलस का प्रोसीजर बाद में देखेंगे.
Okay.
So why did you take a negative?
I didn't take. It came. mg and displacement are in opposite direction. mg is downwards. This distance is L into 1 minus cos theta. L into 1 minus cos theta. Am I right?
Yes.
This is upwards displacement. mg is downwards. Force and displacement, if they are in the opposite direction, I will have to take cos because of dot product. Right?